Before we move on to the molecular phylogenetics portion of this analysis, we need to translate our DNA sequences. So molecular phylogenetics can either be based on DNA sequences or amino acid sequences. But because our data is DNA that encodes 4 amino acid sequences, we need to translate these sequences into amino acid sequences for our analysis. And the main reason for doing this is to ensure that if gaps are placed into our multiple sequence alignments, and I will show you what a multiple sequence alignment is in the next video, but we need to ensure that these gaps are inserted between codons and not within a codon. That's what often can happen when performing a multiple sequence alignment using DNA as your data versus amino acid sequences as your data. In the previous video, we went through the trouble of combining our sequences into a multi-sequence FASTA file, and then we added annotations to this file from our BLASTX searches. So we need to use these sequences, and we need to translate those sequences. So if you already have this file completed, go ahead and use it. If you don't, you can go ahead and use mine. So go to my website and download the second FASTA file link, or you can just open it in a new tab. So right mouse click, and I'll open this in a new tab here. And here is my multi-FASTA file. To translate our sequences, go ahead and click on the Transeq link on my web page, and you can find that down here, emboss Transeq. So if you right mouse click and open that in a new tab, you'll see it here. And as in BLAST, it has a sequence input window and it has a codon table. With this, you'd want to copy in one sequence at a time into this window. So let's go ahead and copy in the first FASTA sequence. Copy it, paste it, and make sure you change your codon table to invertebrate mitochondrial. Now you have the option of selecting which frame to translate, because it does not know where your what frame your amino acid is going to come from. However, you can also select all 6 frames and then click submit. So here are our results. Let me go ahead and make this a little bigger. And so what we see, what you want to look for the FASTA sequence that does not have any asterisks in them. The asterisks represent stop codons, okay? And you'll see many of these have lots of stop codons in them. Here's a stop codon. Here are several stop codons. Here are several stop codons. The one sequence that does not have any stop codons in it will be this one. Now notice X is not an amino acid. What happens here is that when this algorithm is translating in the DNA sequence into an amino acid sequence, oftentimes it comes to the end of the sequence and it may not have the triplet base pairs that it needs to translate that code into an amino acids. It may have 2 left over, it may have 1 left over. That does not translate into a codon, so it then just leaves an X there. So this X can be deleted when we copy and paste this into our file. This is the sequence that we want to keep. Highlight it, copy it. Now we want to create a new text file to store these amino acid sequences. So we can go ahead and use Notepad, and we can paste the sequence into Notepad. There is our first translation. So now we want to wash, rinse, and repeat for the rest of your sequences. So just to show you another example, actually I want to show you the mistake that I frequently made. So if you copy this sequence, and for example the second sequence, which is called spider N, go to your second tab, and then we want to submit another sequence. So go ahead and just click input form. It takes you back to the beginning of the Transeq input page. Paste in the sequence, change the frame to all 6 frames. Now oftentimes what I did is that I forgot to change the codon table. Click Submit. So once you see your results, you'll then begin to look for that one sequence that does not have any stop codons. And so what happens, you'll see that that first sequence has a bunch of stop codons, second sequence has stop codons, third sequence, fourth sequence, fifth sequence, and sixth sequence. So you begin to wonder, what in the world just happened? What happened was that we forgot to change the codon table to invertebrate mitochondria. And so if you go back to the input form, paste in the sequence, put in the correct codon table, and then do a 6-frame translation. Click Submit. Now, when we view the results, we can observe that the first sequence has a bunch of stop codons in it, and the second sequence does not have a single stop codon in it. So this is our winner. Here's a stop codon, stop codon, stop codon. So copy and paste into our text file.